Hey everyone, thanks for joining. Today's session is going to be on it will be given by Shai Paul. He will be speaking on TensorFlow Hub. So we'll stop for a bit. We first of all we try to go ahead with the session. But before we do that, we'll just wait for 5 more minutes. Then I'll pass along the control to Shai Paul, and then he can go ahead and provide his session on TensorFlow Hub. So before we start, just a quick introduction about a TensorFlow user group. The TensorFlow team at Google has started this initiative of having local chapters in different cities. So within India, we have different TensorFlow group chapters. We have one in Mumbai, we have one in Kolkata, and we have other in different cities. So this user group belongs to the city of Pune, where we have in the past as well tried to organize events. Um, but right now, because of the pandemic, we have now shifted to and online only events. Uh, so I hope that you guys have a good intuition of what we're trying to do with this session. So before we further go ahead, uh, I'll quickly introduce uh, the TensorFlow user group Pune and what we exactly do. So this was a bit about TensorFlow user group Pune and exactly what we do during in terms of imparting knowledge of TensorFlow towards all the users that we will find. So today's session, that's what is about TensorFlow user group Pune. So today's session is going to be on TensorFlow Hub, uh, which is if you have worked with Docker, it's actually a hub for different machine learning models. So let's say if you want to work with an image processing model and you don't want to train it from scratch, you can directly go to TensorFlow Hub. You can specify your requirements, and you will get a pre-trained model, which you can then go ahead and use that. So it's pretty well integratable with different technologies. By different technologies, I mean it's pretty much integratable with with Collab for learning. So it's just plugging in it in Collab and then go ahead and train your model. Uh, so this was, and of course, I will have a more detailed overview of it. So before we start, a brief introduction about Shai first. I have known Shai for a couple of years now. He's a Google developer expert in machine learning. He's also a deep learning associate at PyM at Search. And he has done a lot of these events in the past. He's also a co-organizer for TF UG Kolkata. He's also organizer for UDG Kolkata, and I think he has a lot of great knowledge when it comes to machine learning and specifically TensorFlow. Uh, so right now, what I'm going to do is I'm going to pass along controls to Shai, so that he can quickly go ahead with his session. All right. Let me quickly remove myself from the stream, and I'm going to pass along the session to Shai for. All right. Let me add it to the stream. Remove myself from the stream now. Uh, yeah, sure. I'll make sure that you guys can hear you are able to hear me as well as Shai. All right, Shai. I'm going to add you to the stream.
Hi, folks. Sorry that I'll have to turn off my video because I'm on a limited internet connection. As you might know, that previous week we went through a cyclone named Amphan, which has kind of stopped our internet services in most of the places here in Kolkata. So I'm currently on limited internet connection, Geo 4G to be exact, and I have got bunch of other stuff to do for which I'll have to save on the internet bandwidth. So sorry about that, and I uh, I would like to thank all of you and also the organizers of TFUG Pune for organizing this session, and special thanks to you folks for joining today. And good morning if you are from India, or yeah. So that's about it. Uh, I hope I am audible, and I'm going to be quickly sharing my screen. And after I share my screen, I hope Akshay will add it to the stream so that you folks can see it. Yeah, I think my screen is also visible to you guys. uh okay. So without further ado, I'll get started. uh So again, reintroducing myself shamelessly, I am Sayak. I am a deep learning associate at PyMedSearch. I work at the intersection of computer vision and deep learning. And of the work, I like to write technical tutorials and deliver sessions like this at developer meetups and conferences. I really enjoy that part. So today I'm going to be talking to you folks about TensorFlow Hub, which is a holistic repository of state-of-the-art machine learning models across a various number of domains, that too spanning across a number of different tasks, which we will get to see in a moment. So the ideal audience for this session would be the machine learning developers that have worked with TensorFlow and Keras before, because as the name suggests, it's TensorFlow Hub, so it's not compatible with other frameworks like PyTorch, but TensorFlow Hub integrates pretty well with the entire TensorFlow ecosystem, including everyone's favorite Keras. So yeah, this is going to be the rough agenda of this session. I'll be quickly introducing TensorFlow Hub, so to make it a bit more complete, to make this session a bit more complete. We'll be also discussing why it might be useful for a number of different reasons. I'll also be demoing the UI of TensorFlow Hub, that is tfhub.dev, which is a very improved version than what it previously was. The improved UI was announced during TensorFlow World 2019. I'll be also walking you through a number of different use cases where TensorFlow Hub might be really useful, and we'll also be doing a quick Q&A if time permits. And uh, don't feel the need to wait till my talking is over. Just ask your questions right away. I'll be checking them at regular intervals so that uh, we all can make it interactive. So yeah. And let me start the actual session, in fact. So what is TensorFlow Hub? If you ask me, I'm gonna be shamelessly reading out the official statement from the TensorFlow Hub team, and it reads, a collection of state-of-the-art pre-trained models, that is pre-trained machine learning models, of course, published by different teams within Google, as well as community contributors like Microsoft, Nvidia, and so on, and also individual community contributors. And one of my college juniors, Audrish, he also contributed his enhanced super resolution GAN models to the TensorFlow Hub repository. So TensorFlow Hub is open to contributors like you as well. So that's about it. So why TensorFlow Hub might be useful? So this is this is just one of the scenarios where TensorFlow Hub might be useful. I'll be also discussing some of the other scenarios, but this is one of the things that really interests me personally about TensorFlow Hub, that is the ability to use state-of-the-art models right away in my own tasks. So one of the primary reasons of putting together a system like TensorFlow Hub is to enable machine learning developers across the world to take advantage of the state-of-the-art machine learning models by making them more and more accessible to them. And uh, TensorFlow Hub's primary focus is uh, usability. It's really easy to use, so that the machine learning developers that do not have that advanced level expertise yet they can also take advantage of state of the art machine learning models to just experiment and quickly iterate through. So clearly enough, TensorFlow Hub can cater to two different worlds of machine learning practitioners, like machine learning engineers who want to build models and integrate them as a part of a larger system, and also machine learning researchers who want to be able to do quick ablation studies across different state of the art machine learning models. So I think TensorFlow Hub can holistically cater to both of these worlds of engineers and machine learning researchers at the same time. And transfer learning is really one of the most important concepts these days in deep learning. At least I think so. And transfer learning is really very easy to incorporate with TensorFlow Hub models that do across a different number of domains, like images, text, audios, videos, and spanning across different number of tasks belonging to each of these different domains. So that's pretty interesting, in fact. And it also gives you the opportunity to directly contribute to the wide machine learning ecosystem. Let's say you have trained a pretty state of the art model on a particular task, and you would like to give it back to the community for its benefit. So it also provides you a tremendous platform that way as well. Okay, so I'll quickly see if I have got some questions. It looks like I don't have any. In that case, I'll just proceed. So yeah, I'll now be quickly demoing the UI of TensorFlow Hub, that is tfhub.dev. I'll quickly stop sharing the presentation. I'll instead be sharing. Yeah, I hope my screen is now visible, and this is the home page of tfhub.dev. This is the one. This is the URL, tfhub.dev. So it looks like a kind of a search engine for models trained in the TensorFlow ecosystem. Let's say I want to be able to make use of a MobileNet model, pre-trained MobileNet model. So I'll just search with MobileNet, and I should be able to get one. Here you can see the model is published by Google. It was last updated on 19th of March 2020, and it also has a very brief description and the data set on which it was trained on. So this particular model is for running off-the-shelf image classification, and here you can see the number of different variants that are available to you for instant usability across a number of different image shape variants and stuff like that. So if you want to be able to just use the MobileNet network without the classification part, that is you want to be able to use the MobileNet for extracting features from your custom datasets, that's also possible. You would just click on the feature vector part, and yeah, you will get everything that you would need. So yeah, it's also accompanied by a collab notebook that would walk you through the basic usage, and here you can see the basic usage as well, which is pretty cool. uh, so yeah, it also walks you through how would you fine tune with this particular model. So these are also there. And one amazingly important, uh, rather just important thing, sorry about that wrong usage of phrase, it also comes with a number of different formats, right? You have the TensorFlow JS variant of this particular model, that two different versions, right? I think that's pretty cool. And if you just search with MobileNet Lite, then you might get a TensorFlow Lite variant of it. So that is pretty cool. Let's say TF Lite, yeah, and let's say this, and yeah, we have one. So it was published by some other contributor, but yeah, it has it, right? TensorFlow Lite variant of an image classification model ready to be used for running off the shelf image classification. And here you can see the size of the models as well. So it's really a holistic repository of different machine learning models, making your journey of onboarding really easily. Here you can see all the different kind of domains that are available, the kind of different formats that are available. Even we have models on TensorFlow Hub that's compatible with Coral and stuff. uh, and yeah, basically this is about it. Let's say you want to be able to do question answering, so that's also possible. Let's say question answering. So yeah, we have question answering as well. So here you would see all the different stuff. For, let's say, we would want to run off the shelf inference, that is, you would just pass a question to the model and you would just like to receive an answer. That's also possible. So I think that is pretty cool. Also, let's say you are looking for object detection, and that's also possible. This is the mobile net, everyone's favorite, and we have a TensorFlow Lite variant of it, and also a TensorFlow JS variant of it. So all of this stuff is really possible, and I would really encourage that you dedicate some time for playing around with it, and just uh, feel encouraged to try out all the different examples that accompany all these different models and stuff, and also the different variants like TensorFlow JS variant or TensorFlow Lite variant. And if you run into any issues, feel free to post your issues on the GitHub repository, or you can use the alias discuss at the tensorflow.org. That's also useful. So I'm going to be quickly switching to my presentation deck. So just allow me a moment. Yeah, I hope this is visible now. So that was really a quick demo of the UI of TensorFlow Hub. I hope you are kind of convinced that TensorFlow Hub can be useful for a number of different reasons. So quickly switching gears. So yeah, this is the holistic view of the TensorFlow Hub repository, showing you a number of different models that are possible, really. So quickly switching gears to different use cases that come with TensorFlow Hub. I like to start off with the classic image classification scenario, where we are interested in just running off-the-shelf inference with a pre-trained image classification model. So let's see how easy it goes. So the first and foremost thing is to specify the URL, the TensorFlow Hub URL of the model you are interested to run inference with. Then you typically load it in a Keras layer, which is everyone's favorite. Then you would construct a Keras sequential model with that particular Keras layer that you just constructed with the TensorFlow Hub module. You can specify the input shape. So these arguments are all there. Feel free to check out the documentation for that. And just that you can run inference with this particular classifier that you just built in the previous step, like that. It's just so you also get the stock methods that you would normally get with a Keras model. That's fit, predict, and stuff like that. Fit might not be available if you are using the classification network, because the sole purpose of this particular network is to just run off the shelf inference on your images. It can also be used in videos as well, rather extended to be used with videos. So I have also linked the entirely worked out tutorial where you can see this in action, and you can also play around with it. No worries, I will share my deck with all of you so that you can refer to it when it's needed. So that was a quick example of running off-the-shelf image classification inference with TensorFlow Hub-based modules, and you can typically provide another URL of any other model. Let's say Inception v3 probably, and that's absolutely possible. So let's take a bit more involved scenario where we are interested in running image classification on our own custom datasets. That's popularly known as transfer learning, in fact. So transfer learning has got two different use cases, like pre-computing bottlenecks and running those pre-computed bottlenecks through a fully connected network for classification, or the other use case, which is more popular, I feel, is fine tuning. So let's see how that goes. So here we are specifying the feature vector network. This particular network does not have any classification top like the previous one. So the steps remain the same, although you are starting by specifying the TensorFlow Hub URL of the network you are interested in. Then you are wrapping it in a keras layer. You are also specifying the input shape. Then you are constructing a custom image classification model to aid accordingly with your custom dataset. And as you can see, the feature extractor layer has got a parameter called trainable. If you are interested in fine tuning it, feel free to go ahead and set trainable equals to true. But if you are not interested in that, you can also set it to false. So, and after you are done building your custom classification network, you can just compile and feed it right away. So you can also find the worked out example in the link below. So yeah, feel free to just go ahead and play around with it. So most of the feature extractor network that are available over TensorFlow Hub can be fine-tuned, but some of them are not yet compatible for fine-tuning, so you will have to take some extra care there. But most of the networks are fine-tunable, in fact. So let's take one of my most favorite demos of TensorFlow Hub, that is running off the shelf very cool style transfer stuff. So let's say we are interested in obtaining stylized images which would look as cool as this one. So let's see how that goes. Let's say our content image is the left one, and the style image would be the bit right one, right? And we are interested in running style transfer. So this is all the important pieces of code that's needed in order to generate a stylized version of the content image like this one. This is all the code, right? This of course does not include the library imports and the image pre-processing functions, but this is all the major piece of code that's needed in order to generate a stylized image like you are seeing here. I think that's pretty cool, and I would really encourage you to try this image with other style images and see what results you get. So feel free to also tag the TensorFlow team in case you are tweeting about it. So yeah, and let's take another very cool example that's of generating novel faces. Again, this is also like running off the shelf inferencing. Here we would see how to use a progressive GAN to generate novel faces just by using random vectors of dimension 512. So yeah, let's see. So again, you would start by providing the URL of the tfhub URL of the model. In this case, this is a progressive GAN. So 128 actually denotes the dimension of the image that is capable that the particular network is capable of generating. Then you are specifying that then we are specifying that we are interested in generating 20 images, and we are also specifying what would be the latent dimension of the vectors from which those images would get generated. And then we are passing the latent dimension, the latent vectors through the progressive GAN model, and then we are just visualizing it. So as simple as that. And this is one of the images that I got. I have also linked the worked out example for this, and feel free to check it out and generate cool faces, and let's see how realistic it gets. So yeah. Another example, let's switch gears from computer vision, and let's enter into the NLP domain a bit. So here we will be seeing how to train a custom text classification model using pre-trained embeddings, which is also a kind of transfer learning for NLP based tasks. So again, you will start by providing the URL to the pre-trained embedding files. And if you are interested in fine tuning them, I think you should fine tune actually for most of the cases, I feel. But it really depends, and it varies from use cases to use cases. Here we are fine tuning. That's why we are setting the trainable parameter equals to true. We are wrapping the pre-trained embedding in a keras layer. We are then constructing our custom image classification model, text classification model. We are interested in a binary classification, that is spam or not spam. That's why we are specifying the activation to the last activation unit to be sigmoid, and yeah, voila. Then you just call model.compile and model.fit. And of course, I have not included the text pre-processing stuff that's needed, but again, this is a majority of the code that will be useful for you, I feel. And as always, I have also linked to the worked out collab notebook, which you should be uh, uh, playing around with in case if you are interested in trying out the text based models. And TensorFlow Hub is widely known for its support for other tasks as well. Let's say you are interested in enhancing the resolution of your images, and then you would like to train an image classification model on those enhanced images. So feel free to try out the enhanced super resolution GAN model for that. Object detection is also supported, although I'm not yet sure if it's supported for custom training use cases. But yeah, you can definitely run off the shelf object detection with TensorFlow Hub based models. Question answering is also supported, which is very fun, I think. And there are a number of different tasks that you might be interested in exploring. So feel free to check out them on tfhub.dev. Okay, so as I mentioned, TensorFlow Hub also gives us a tremendous opportunity to publish our own state-of-the-art models. So here I have linked the guidelines for that. So I think it's really easy, and it makes it very convenient for the community, for the broader machine learning community. So feel free to check it out in case if you're interested in publishing your own models with TensorFlow Hub. And I have made the slides available here. I'm sure Akshay has got the link as well. He might want to also post it in the comments, or he might want to also display it on the screen so that folks can make use of it. So it's bit.ly/tf hyphen hub. So it's really easy. In case if you're interested, feel free to refer to it as needed. And I'd like to get connected with all of you. Uh, let me know know about any feedback you might have on this particular presentation. Let me know if I could improve it in any way. And Rising Sayak is my Twitter ID. So if you have anything to convey to me, feel free to use it and let me know about it. So that's all from my end. So let's see if we have got any questions, and I'll be happy to answer them. Let's see. Let's take them one by one. Looks like I have got plenty of questions. Omkar, I hope it was not an issue for the screen resolution part. uh, VAPO, Vapor, I guess. Yeah, Vapor Inside asks, can we have a small walkthrough from getting a model from TensorFlow Hub to running it? I guess you already had it. Uh, could any developer upload models to TensorFlow Hub? Yeah, of course, as long as one is following the guidelines that's enlisted in the link that I mentioned. That is the link of this one. Any developer can absolutely publish their models. I wanted to do the transfer learning for breast cancer, to be precise. So any pre-trained models available, mention, would be very useful. Neeraj, I'm not sure if the pre-trained models would be directly applicable for your use case, because in my experience, what I have seen is the pre-trained features from ImageNet or any other large datasets like ImageNet 21K or Open Images or JFT or something of that sort do not really translate that well when they are applied to medical imaging and stuff like that, even if they were like trained very well. So I think in the near future, what I would like to see is more domain specific models, specifically in the domain of medical imaging. But yeah, feel free to go ahead and try out the pre-trained image classification models that are available, and yeah, let the TensorFlow Hub team know about your findings. uh, Akshay also wondering if we could extract a specific layer of the model to our code instead of the complete model. Yeah, so this is one of the problems of TensorFlow Hub models. Like if you use tf.keras.applications, let's say VGG16, we can typically index into a particular layer of that model, and we can do whatever we would like to do. But TensorFlow Hub does not give that flexibility. So it's something to take note of. And it was a great question. Thank you. Do you have explainable AI models? Are you asking something like a like GAM based models, or generalized additive models or something like that? If yes, I don't think TensorFlow Hub has any GAM based models, like generalized additive models or something like that. Yeah, so I guess that answers your question. Yeah, so I guess I have answered the kind of questions that were posted, but yeah, feel free to ask anything related to machine learning. It does not need to be very specific to TensorFlow Hub, but I would really appreciate if we could maintain some specificity there. But yeah, I guess Invent was asking if you are looking for GradCam based models. Yeah, still, I mean, you will have to, code it yourself. TensorFlow Hub will not give it like out of the blue, as far as I know. Yeah, so uh, please feel free to ask any other questions you might have.
All right, Shai. Uh, I think that there, I mean, if there are any other questions, then of course we can take that up. But I think uh, this was a great session. I will want to end that, in a couple of minutes because we are of course running short of time. Uh, I'm going to remove your screen, if, or maybe that's fine. I'll just keep your screen right there. So yeah, I'm just waiting if there are any other questions for like a couple of minutes, and then we can quickly go ahead uh, with with some of the future plans for the activity, and we also have some other speakers. So yeah, so I think Satya already has a question. Shai, if you want to take that up.
Yeah. Not specific to Hub. What's the recommended method to deploy machine learning models? Flask server, TF serving, or Java, TensorFlow, to name a few. Uh, it really depends on the kind of use case that you are catering to. Maybe you are interested in developing an entire end-to-end architecture, like on a very large industrial basis, where you'd like to take advantage of some of the DevOps practices with machine learning. In that case, I think TensorFlow extended, when coupled with Kubeflow, would be a great solution. But again, if your use case is way more simpler, then I think the TensorFlow serving would be pretty great for that. But in case if you are looking for anything specific, let's say you would want to deploy your TensorFlow model to edge devices or mobile devices or something like that, you can still take advantage of Firebase based pipelines and TensorFlow Lite in a pretty holistic manner. If you want to take advantage of more of the web capabilities that come with TensorFlow JS, that's another option to explore. So yeah. Another question is, does SOTA models do SOTA models require SOTA GPU, CPU, or yeah, it again, vapor inside, it depends on the kind of use cases that you are trying to catering to. If you are interested in running off the shelf inference with the SOTA state of the art models, then I think having a commodity computer will typically work. But in case if you are interested in running transfer learning or even fine tuning your models, having a decent GPU would be helpful. And by decent GPU, I do not mean the one that Microsoft published. That's the supercomputer. Having a single Tesla K80 would be great. Another question is, if I have images of dimension like say 299 cross 299, if I have to use transfer learning, most of the pre-trained models have input shift fixed. In that case, will it be okay to compress images or reshape? Again, it's a matter of experimentation. I cannot really for sure say that it will match up to your expectations, but inception v3 and inception v3 based models were trained using 299 cross 299. So I would first start off with inception v3 based models, and based on the kind of performance and training time I am getting, I would consider the further options like resizing images or compressing images and so on. And but to my understanding, some of the models actually support dynamic shapes. So you should be able to take advantage of that as well, dynamic square shaping and stuff.
Very good, thanks. And of course, I just want to add to Satya's question on deploying ML models. I think it depends on the use case, as already Shai mentioned. So coming from industry, what exactly we do is we have a pipeline for such stuff. So we in the pipeline itself we deploy our models, and we want to make sure that it works pretty well. So we keep on monitoring the models and making, and also we have to train it again and again based on the new data that comes in, let's say every week or every day. Shaik, we also have another question if you want to take that up.
Yeah, so the one that you are currently seeing on the screen, I think it's probably the easiest way to get started with TensorFlow Hub based models. And yeah, adding on top of just what Akshay said, if you're so it's regarding Satya's question. If your use case is way more involved, let's say it's for larger industrial use cases where you have needs like retraining your model based on the frequency of the data drifts or concept drifts and stuff like that, and you are interested in automating the entire pipeline, like when new data is coming, you would just swap the the previous version of the model and just retrain another one and automatically deploying it. For those use cases, I think TensorFlow extended and when combined with Kubeflow can do wonders. So yeah, but I have seen companies have their own custom built pipelines for that. So yeah, it really depends on the kind of use case you are interested in catering to.
Yeah, definitely. Thanks for that, Shai. I think we will now end the session if that is okay with everyone. Thanks. I mean, especially I would want to thank Shai for taking the session, especially in these times. I mean, the session was scheduled actually for last week, last weekend, but we had Saiknam Khan and I wanted to make sure that everybody could join, and of course, our speaker is also from Kolkata, so I wanted to make sure that he's also doing okay and he can join whenever he can. So quickly, I'm just going to yeah. So I just want to thank everyone for joining. Um, to the session. We have other sessions planned as well. So we have the next session. I presume is going to be next week or next week, where we have a speaker from Reliance Geo. Name is Nida, and she is speaking mostly on NLP and how she's using that in at Reliance Geo. Just an overview of that, and of course, she has solved other use cases. And I think she'll be coming and speaking on that. And we also have some other speakers who are pretty great at what they do, and they will also be joining for some sessions. So feel free to reach out to us. Feel free to give us any feedback that you want. Um, I think one last question is Neera's question. Shai, I'm adding you to the stream if you want to take that up.
Yeah,
Let me
sure.
know.
Sure. Neeraj asks, how can I train models having dataset in form of TF records using dot example of TF records? I'm mainly finding training using TF1. Yeah, definitely. Let me share my screen for that. Uh, application. Sorry. Yeah, so uh, I did actually experiment with uh, TensorFlow records and how to make the best use of TensorFlow records, specifically in image classification based models. I guess I have one example that shows this. Let me see. Yeah. It has training models with TensorFlow records. So yeah, it shows this. So here I have used the particular tf.keras.applications.resnet50, I guess, but you can typically swap that out with any TensorFlow hub based modules and construct your own custom classification network that's suited for your dataset. But yeah, it's possible to use TensorFlow tf records for that. So this is the URL of that. So if you go to tf2.o hacks, this is the this is the URL. If you just search with tf2.o hacks, you will, I guess, you will be getting this one. And yeah, inside tf.data exploration, you will get all of these notebooks that I experimented with. So I guess that answers your question.
Yeah, I think I've already also posted the same in the comments as well. So if you want to have a look at that, feel free to do that. And of course, feel free to follow Shaik as well on GitHub. He posts amazing work on GitHub. So yeah, so with that note, on that note, I think Shaik, we can stop this session. I'm going to go ahead and stop the session. All right, thank you for joining everyone, and feel free to leave your feedback in the meetup section, or you can also reach out to Shai directly, or you can reach out to me as well over LinkedIn. All right, thank you everyone for joining, and I'll see you in the next session. Thank you so much.